Hi, we're going to have a look at standard deviation here. Standard deviation gives us an idea of spread or variance or consistency for a group of data. So the standard deviation measures the spread of data about the mean value. A low standard deviation means that most of the numbers are close to the average. A high standard deviation means that the numbers are more spread out. So the higher the standard deviation, the more spread out the data values or the numbers are. So let's have a look at how we actually calculate it. So to calculate the standard deviation, we use this formula. So we've got some new symbols in there that you won't have seen before. So let's have a look at them. So here we have x bar. So x bar is the mean. So we just calculate the mean by adding together all the data values we have and dividing by the number of values. We have an n down here. N is simply the number of data values. And we have this Greek symbol here, the sigma sign. So that just means the sum of. So we're going to calculate these values and then add them all together. So we'll see how to do that in the example. But again, what does the standard deviation tell us? It gives us an idea of the measure of the spread of the data about the mean value. So let's have a look at a couple of examples. So find the standard deviation or the SD of 4, 7, 6, 7 and 1. So first thing we need to do is find the mean, which we are now calling x bar. So we just add together the 5 numbers we have, 4 add 7 add 6 add 7 add 1, divide that by 5. So the numerator there comes to 25. 25 divided by 5 is just 5. Right, so you've done that before, you've done that in primary school, you've done it in S1 and S2 as well. Right, let's have a look at what we need to do next. So let's have a quick look down here at the formula. So we have x minus x bar, so x is just our data value. So back to the top there, so 4, 7, 6, 7 and 1. So we're just going to write a table out here. So those are our data values. We're then going to subtract the mean from our data values. So 4 minus 5 is negative 1, 7 minus 5 is 2, etc. And then the third column here, we're going to square these values. So I've put negative 1 in a bracket here. If we square negative 1, we get positive 1. If you're using your calculator to do that and you don't put a bracket around it, what your calculator will do is square 1 and then put the negative sign in front of it. So you must put your negative numbers in a bracket if you're using a calculator. Just do that every single time. You get used to doing it, it becomes second nature. And when it comes to your final exam, you've trained yourself to do it every single time. You're not even thinking about doing it. Okay, so get into good habits. And then what we're doing here, we're adding together these values. So 1 add 4 add 1 add 4 add 16 is 26. Why have I done that? Because it says sigma x minus x bar all squared. Remember, the sigma sign means the sum of all of these. So I've worked out these for all 5 of our values, and then I've added them together to get the 26 there. So then after that, we're substituting in. So the top row of our formula, sigma x minus x bar all squared, is 26. N, remember, is how many data values we have. We have 5 data values. Subtract 1, which is going to be 4. And then just evaluate that on our calculator. And as always, guys, the SQA want unrounded then rounded answers. So 2.549 ... which rounds to 2.55. Right, let's have a look at a second example. So that's basically most of what you need to be able to do for standard deviation. It is just using a formula, really. So find the standard deviation of 0, 12, 2, 8 and 3. So again, find the mean first. So x bar 0 plus 12 plus 8 plus 2 plus 3 all over 5, which comes out as 5 again. And then do the table again. So 0, 12, 2, 8 and 3. So x minus x bar, so our data values subtract the mean each time. So 0 minus 5 is negative 5, 12 minus 5, 7. Do the other ones, square them all. So negative 5 squared, remember, put it in a bracket. These values should never be negative. So find the sum of those as well, which is 96. So sigma x minus x bar all squared. Again, it's just the sum of this column. The top line of the formula is just the sum of this column, which is 96. N minus 1, again, I've got 5 values. 5 minus 1 is 4. Substitute into the, evaluate it on the calculator, unrounded, then rounded answer. Okay, so there's 2 examples. Sometimes we are asked to compare what we have found out. So compare the mean and standard deviation from question 1 and question 2. So quick recap. So in each one, x bar or the mean was 5. Question 1, the standard deviation was 2.55. Question 2, the standard deviation was 4.90. So if we're ever asked to compare these, what we're really being asked is to show that we understand what we are calculating. So if I'm comparing the mean values, I wouldn't actually use the word mean when I'm doing that. I'd be showing the examiner that I understand the mean as an average. So the average scores in question 1 and 2 were equal. Okay, so I'm not using the word mean, I'm using the word average. Now I'm going to compare the standard deviations together. Again, going back to the very first page here, a low standard deviation means that most of the numbers are close to the average. A high standard deviation means that the numbers are more spread out. So because we've got 2 standard deviations, we're basically comparing them to get an idea of how spread out the data values are. So question 2, standard deviation's higher, so the scores in question 2 were more varied than question 1. Again, I'm not using the word standard deviation there. I'm showing that I understand that standard deviation tells us when we're comparing 2 sets of data, we can tell that one is more varied than the other. If we have a quick look at the numbers that we had in question 2 and question 3. So question 2 here, sorry, question 1 and question 2. So question 1 here, an average of 5, they were reasonably close to 5, whereas in the second question they were more spread out, so we'd expect a higher standard deviation here because the scores are more varied. Okay, right, I'd now like you to rewind the video and to get the pages that I've just gone through there into your notes jotter. Thank you.